All right. Hi guys, we're back ready to do lesson 4 of chapter 5. So we're on section 5.4, talking about polygons and angles. A polygon, hopefully you know that a polygon just means that it's a closed figure that cannot intersect and doesn't have any curves in it of 3 or more lines. So knowing that a polygon, it cannot cross itself and it doesn't have any curves and it's a closed figure, would this be a polygon? Well, the answer is no, because it's not attached at the top. This is an open figure. Would this be a polygon? Well, the answer is no, because it has this curve right here. Okay. Would this be a polygon? And again, the answer is no, because it intersects or it crosses itself right there. So polygons are closed, non-curved figures that don't cross themselves. Okay? Here's a map of the United States, and it says, find all of the polygons, the states that are polygons, and write them down. Write how many of them there are, and name them. Well, polygons, again, if we go by those rules, they don't intersect and they don't have rounded or curved lines. So Texas would not be a polygon because of this coast right here is a curved line, and this part right here that goes into Mexico is a curved line. So we're looking for straight lined states. Well, New Mexico is one of them. So we would write down New Mexico. And it says, how many number of segments or how many numbers of sides does it have? Well, it has 1, 2, a little one here, 3, 4, another little one, 5, 6, 7, 8. So the number of sides that it has and the number of segments is 8. Well, let's find another one. If I would go directly above New Mexico to Colorado, that all has straight sides. And Colorado has 1, 2, 3, 4 line segments. If I continue looking, I've done New Mexico and I've done Colorado. So now let's look at another one. Are there any more that have straight sides? Well, yes, right next to Colorado is Utah. It has straight sides, and it has 1, this little one in here, 2, little one here, 3, 4, 5, 6. So Utah has 6. So now I've covered Utah. Looking straight up from there to Wyoming, Wyoming has all straight sides. And it has 1, 2, 3, 4 straight sides. So Wyoming would count. And if I look at any more, I'd have to look pretty closely. These all over here, these all have pretty jaggedy edges. They all have curves in them. The book also counts North Dakota, which I guess I would also count North Dakota if I looked at it very closely. Even though, yes, it does have some slants on this side, they're counting that as a straight angle. So they're saying that it has 1, 2, 3, 4. So, like I said, the book also counts North Dakota. If you add North Dakota, that's fine. If you think that because of the slanted angles that you don't want to add it, that's fine too. But we're going to go ahead and put North Dakota on here. And it has 4 segments or 4 sides. Okay, so those are all of our polygon states. So now, let's use this information to apply it to mathematics. If I look over here, this is how you find interior angles. And hopefully you remember interior angles are the ones that are on the inside. Okay? And the equation says that to find the interior sum of angles, to find how much it is all the way around the figure on the inside, you take the number of sides minus 2, and then you take that times 180. So using that formula, we can do any polygon, and as long as we know the number of sides. And there are certain things called regular polygons. Regular polygons are polygons that have equilateral, which means that all their sides are the same length, and they're equiangular, which means that all the angles are the same. So a regular polygon, like a stop sign, that's a regular octagon. All of the sides are the same length, and all of the inside angles are the same. So now let's look down at this chart. Let's say that we have a triangle. It can be any triangle. We know that the inside angle, we talked about this yesterday, the inside angles of a triangle equal 180. Okay? If we have a four-sided figure, one way to think of that is how many triangles can I divide that into? Well, the answer is 2. I could draw a line right through here, and I have one triangle here, and I have one triangle here. So I have 2 triangles, which means I have 2 180s, and 2 times 180 is 360. If I use the formula to do that, remember it's the number of sides. I have 4 sides, so I take 4 minus 2 times 180, and 4 minus 2 is 2. So I take 2 times 180, which is where I got the 360. This 2 out here is also how many triangles should fit inside of there. Okay? So not only is it the number of sides minus 2, it's also how many triangles should fit in the figure. Let's try it down here. This is a pentagon. It has 5 sides. It has 1, 2, 3, 4, 5 sides. And if I broke it into triangles, I could break it into 3 triangles. So 3 times 180 is 540. It has 5 sides. If I take 5 minus 2, I should end up with however many triangles I could put in there, which was 3. And I would still end up with 540 angles. That means this angle plus this angle plus this angle plus this angle plus this angle. All 5 of my angles added together should equal 540. So now let's look at some examples down here. This is doing the same thing that we've been doing. Let's look at a hexagon. Well, if you don't know what these shapes are, then you probably need to go look them up somewhere, because you're going to need to know them for tomorrow's project. You're going to need to know them for future reference whenever we're talking about polygons. But a hexagon is a 6-sided figure. So I know that a hexagon has 6 sides. And knowing that, remember the equation says I take the number of sides minus 2 times 180. Well, knowing that a hexagon has 6 sides, I have 6 minus 2 times 180. 6 minus 2 is 4, so then I have 4 times 180. And 4 times 180 gives me 720. So a hexagon, the inside of a hexagon should measure 720 degrees. Let's look at an octagon. Again, if you don't know what these are, please look up these words. An octagon means that it has 8 sides. Think of an octopus. An octopus has 8 legs. O-C-T means 8. So an octagon has 8 sides. Again, it's number of sides minus 2 times 180. The number of sides is 8 minus 2 times 180. 8 minus 2 is 6. And 6 times 180 is 1,080. So an octagon, the inside angles of an octagon, if I went to a stop sign and I measured all the inside angles, they should equal, 1,080 degrees. Okay? A 15agon. After you get past 10, 10 is a decagon. Okay? D-E-C-A means 10, so decagon means 10-sided figure. After you get past that, they don't give them fancy names. They just put however many sides it has, and then they put the word gon behind it. So this means 15 gon, which means 15 sides. G-O-N, gon means how many sides, or sides. So a 15 gon is a 15-sided figure. So we have the number of sides minus 2 times 180. The number of sides is 15. So we have 15 minus 2 times 180. 15 minus 2 is a 13. And 13 times 180 is 2,340. So a 15agon, with the word 15agon, is 2,340 degrees on the inside. Okay? So now let's use this information over here. Well, this says you figure out how many the interior angles are. So in this case, they were using a 6-sided, a hexagon, a 6-sided figure, and 6 minus 2 is 4. 4 times 180 is 720. This is the interior angles all together. But let's say that I want to figure out how much 1 is. Well, if I know that all of them together is 720, to figure out how many 1 would be is the total interior angles divided by the number of sides. Let me move that over so you can see it. The total interior angles divided by the number of sides. So here we know that the total interior angles is 720. Again, we're talking about a hexagon. So I have to divide that by the number of sides, which is 6. The total interior angles, 6 minus 2 is 4. 4 times 180 is 720. So my total interior angles is 720. And again, a hexagon has 6 sides. So it's 720 divided by 6, which means that it is 120 for one of the angles. So if we had a 6-sided figure, one, two, three, four, five, 6, that means that each of these would have to equal 120 in order for it to be a regular hexagon. Now this one, obviously you can tell this angle is not the same as this angle. This is not a regular hexagon, okay? In a regular hexagon where all the sides are the same length and all the angles are the same, and I can't draw a regular hexagon, I'm not even going to try to, but a regular hexagon, each individual interior angle would equal 120, okay? So let's do it down here, an octagon. Well, first of all, we have to figure out the interior angle. So we know an octagon is 8, so I have 8 minus 2 times 180, which is 6 times 180. And 6 times 180 is 1080. So we take this number, because this is the interior angles, the total interior, divided by the number of sides. Well, I have 1080 divided by the number of sides, which is 8. And 1080 divided by 8 is 135 degrees. So if we went out to a stop sign and we measured the number of degrees the inside angles are, it would be 135 for each one of the angles. Okay? Now let's do a heptagon. A heptagon, H-E-P-T, means 7. So a heptagon is 7-sided, so I have 7 minus 2 times 180. Or 5 times 180. And if I took 5 times 180, you took 5 times 180, you would get 900. So a heptagon has 900 as the interior, as all of the sides on the inside. So I have 900 divided by the number of sides. There are 7. So my answer, if I took 900 divided by 7, I have 128 point, we're going to go ahead and make that a 6 because it's in the book it says round to the nearest 10th. Round to the nearest 10th. And if I look at this, my 10th spot, the 5 is in the 10th spot, so I have to look at the number behind it. If this number is 5 or higher, I make this a 6. If this number is below 5, I leave this number a 5. Well, this number is a 7, which means that it's 5 or above. So I'm going to make this 128.6. So one angle in a regular 7-sided figure, heptagon, is 128.6. Go ahead and do F for yourself for a 20agon. Stop the video. When you come back, we'll talk more about angles. Okay, hopefully you had an opportunity to do letter F. Now we're going to go on to exterior angles. We've talked about interior angles. Now we're going to talk about exterior angles. It doesn't matter how many sides, it says regardless of the number of sides. So the number of sides do not matter. Exterior angles is always 360. It could be a 42-sided figure. The outside angles are still going to equal 360, excuse me. So if it's a triangle, the outside angles, remember the outside angles are where if I extend this line, it's going to be this angle right here. Okay? If I extended this line, it's going to be this angle right here. So the outside angles, the ones that are not inside the figure, are going to equal 360. So let's do an example of that. It says find the measure of an exterior angle of each regular polygon. Sorry, I'm way too high. Okay, find the measure of an exterior angle, so a triangle. So we're going to go ahead and draw a triangle. Okay? Again, if I extended all of these lines, the exterior angles are still going to equal 360. So how many lines did I extend? Well, the answer is 3. How many sides do I have? Well, the answer is 3. So I know that it has to equal 360. And I know that there are 3 sides. So if I take 360 divided by 3, I know that in a regular triangle, each one of these has to equal 120, because 360 divided by 3 is 120 degrees. So in a regular triangle, a triangle where the sides are the same length and the inside angles are the same, I have 3 sides, so that's 3x, and it has to equal 360, so then I divide by 3 to get x by itself, and 360 divided by 3 is 120. So a quadrilateral, how many sides do I have? Well, I have 4 sides. So I have 4x, and the outside has to measure 360. So divide by 4, divide by 4. And so every outside angle of a quadrilateral, of a regular quadrilateral, has to equal 90 degrees, because 360 divided by 4 is 90. Now let's talk about an octagon. How many sides are in an octagon? There are 8, so it's 8x equals 360, because all of these shapes, regardless of how many sides they are, equal 360. Then I divide by 8, and 360 divided by 8 is 45. Well, now wait a minute. What do you notice between this number and this number? Well, hopefully you know that 45 is half of 90. But if I look at this, 4 is half of 8. So if I increase this to 16, which is twice, like here's 4, then I took that times 2 and got 8. If I took 8 times 2 and got 16 for a 16-sided figure, I would break this in half again. Does that make sense? If it doesn't, you can always fall back on this. Just do however many sides it is, equals 360, so an 8-sided figure is 8x equals 360. Then you divide both sides by 8, and you got your 45. All right, guys, that's all there is to this section. If you have questions, please bring them in tomorrow. If not, have a great night. Talk to you later. Bye.